Hello, welcome to Code Mindspace, where we teach Python, data analytics, and machine learning. Now, we're going to be looking at how we can predict some data using the linear regression. Okay, now first of all, what we have to do, we have to import our required libraries. Now, before we go further, I did a video on data preprocessing where I did an introduction to machine learning. You can find the link in the description below. So I think from here, what we have to do, first of all, we have to import our required libraries. Import numpy as np equals pandas as pd. Then you see the matplotlib.pyplot as plt. These are the standard. These you see after the as np as pd as plt. I said earlier in our last class that these are just alias. So we have run it. So we'll go here. The next thing we have to do is to load the data set in which you want to work with. Now, when you want to load the data set, what you have to do is you have to give a variable name to the data set you want to load. So here I name my variable dirty data, and after the equals to sign, we are seeing the pd, which represent the pandas. Okay, pd.read_csv. Now inside the bracket, inside the function read_csv, we have the path in which our file is saved in our local machine. Now we see here that I'm calling the variable name and putting the .head function. This .head function gives us just 5 observations of our data set. So if I run it now, you see what we're having. We're having the duration, the pause, the mass pause, and the calories column. Now the next thing we are going to do, we're going just to explore our data, do some exploratory data analysis. We can look for the shape. Now looking for the shape of the data, what you have to do, just call the variable name in which you've loaded your data with, then just type .shape. You see this is the shape. We have 169 rows and 4 columns. All right, now we can also get, if we have a data set of larger columns where it exceeded our view, we can also check how many columns we have. And now we see the dirty data, which has a variable name. We can just say .columns, then you see it, our entire columns will be able to see the duration, pause, mass pause, calories. Now if we want to see the details of our data, just say the dirty data, I think dirty data.info, we get it. So you see everything about the data set will be outputted. You see the columns are total of 4 columns. You see the respective columns, the duration, we have 169 non-null, int 64, you can see each of them. So you can see the memory size 5.4 kilobyte. Now these are everything, every information is contained in the information, the info method or the info function. Now when you want to check the descriptive statistics of, want to get a summary of the statistics of the data you have, you can just do exactly, just call the variable name here that we have, then just say .describe. Once you say the describe function, you've gotten it. So if you run it, you can see where we have the count, means the total number of rows. Okay, now the mean of each of the columns, you see the standard deviation of each of them, the minimum number, the 25% percentile, the 50% percentile, also the 75% percentile. These are the information, the maximum value of each of the column. Now I think this works for only just values that are numeric. Now if you have any columns where they are made up of categorical data, what you have to do is you put the include then equals to, then you write categorical. Okay, categorical data, like that. Okay, so I think that's not a major focus for now, for today, but I've given you the way to go about that. Now the next thing we are going to do is we are going to look at how related are these values. You know, when you are working with a data set, you have to get the features, the columns that relate to what you are doing. Okay, you don't just pack everything. Okay, so this is what we're doing. We'll be looking at the correlation looking at how correlated they are, how related they are. So, and this falls under -1 and +1. Okay, if it is 0, it means there are 0 correlation, but if it is gearing towards 1, means the correlation is increasing. When it is gearing towards the -1, it means that it's a kind of negative correlation. That means the correlation is bad. Okay, so if I run this, you see correlation, I just gave it a variable name. You can give it whatever name you feel like. Then this round here means that, okay, let's take, okay, this round here means that want to round this correlation to a certain significant figure, but I can take this off so that you not be confused. So let's see what happens if I run this. You can see, okay, you can see the correlation. Duration, every column is perfectly correlated to itself. You can see duration to itself is 1, that's perfect correlated. You can see pause to duration. You can see these are the correlation. Now I want to narrow this down to, I want to round it up to let's say 3 significant. I want to narrow it down, so I can just put it. You can see the number after the decimal is 3 numbers. So you can see you can do that as you want, as you feel like, whatever you want. If you want to round it up to 2, it's up to you. Now we can visualize the correlation matrix. Now this thing here is called the correlation matrix. So we can also view the correlation matrix using the Seaborn. Okay, the Seaborn library. I think before we have to do that, we have to import the Seaborn library. We have to say import Seaborn as SNS, I think. Then we'll run it. So you can see, so what happens here is you see the correlation matrix in a visualized form, and this will carry different colors. Now this color map, this C map here means color map. You can set it to any colors you want. We have the Verdis, we have the rainbow, and the rest. So I think it's showing us an error. You say DF is not defined. I think what we have there is dirty data. So I think you will just see perfectly well. It will come out. Now you can see it very clear. You can see now that it's, you see, that means it's showing you that if it's gearing towards the yellow color, it means it's gearing towards the perfect correlation. But if it's going towards the is it the purple, or yeah, that means it is getting towards the 0. Okay, all right. Now I can still set this to another color. You can see I can put the rainbow. You will see it. It will still give us, you see, you can see. So you can use this visualization method to check the correlation. Now the next thing to what we're doing is we can also plot, and we can also plot 2 different columns to see how this column affects the other column. So here we are plotting the pulse against the calories. We want to see how many of pulse, which is the independent variable that will burn the calories of the dependent variable. Okay, and want to present this kind here means that want to present it in a scattered plot. Okay, so and when you do that, you say plt.show. Okay, you can refer to my matplotlib tutorial. I'll put the link in the description below, so you check it. We did a lot of this. We talked about the matplotlib, how to plot. We use the different type of plot. In this case, we want to use the scatter plot. So once you use your plot function, what you do next is to say the plt.show. Okay, that's the reason why we have to import the matplotlib library. Okay, so if I do this, you can see how related pulse and calories are. You can see. All right, now we can also try other columns, the duration columns and the duration column and the calories, now to show you how many hours somebody can work out and how many amount of calories will that person burn. So I think it shows here, so in a scattered plot. So there's it. Now want to do the regression, want to use the regression method. Okay, so we're applying the regression method here. So we're applying the regression method. So I think this is familiar with us. I just want to make this a heading. Then I run it. So want to apply the regression method. Now the regression method, we can use the sklearn to do that also, but in this case I want to start by using the statistical method of the regression. Okay, so there are more easy way to do the regression by importing the linear regression from sklearn, but let's use the statistical model first of all and see what happens. Now we have our x, which are independent variable, which is the duration, and the dependent variable, which is the calories. We want to see how many hours or minutes of a workout can make us burn a certain amount of calories. Okay, so this is from our data. Okay, we just picked one, the x, we make it x, give it the name x, is equals to data. Okay, I think it's not data. What we have there is dirty data. You can remember that's the variable name we gave to the data we loaded. Okay, so now putting this in the square bracket means we choose the particular column, which is the duration. Same thing applies to the y variable we put here. So I think that's that. So now this slope you are seeing here, this slope intercept rp std err, I will explain what it means. Now we are trying to apply the statistical model of the linear regression. Okay, this is how we will apply it. Now this slope stands for slope. Now you see that in our straight line equation or in a linear regression, we have y is equals to mx plus c. Okay, which the m represents the slope, the x represent the x variable, then the c represent the intercept, then the y, which is equals to the mx plus c, means the variable. So it is dependent on the x. So however x increases, that is the contribution it gives to y. Okay, so now this is what happens here. Now we say equals to this entire variables we load here, we say is equals to stats dot, this means statistics dot line regress. Okay, now we have to put the two variables we are looking for. Okay, we're looking for the relationship between these two variables. So that's what regression is all about. Now we see I define a function called my function, so you can give it any name, and I want it to pass just a single argument. Okay, so I say return slope, okay, multiplied by x, which is the independent variable which determines how many of it will give us y. Okay, so plus the intercept. This is the equation of a straight line, you know. Now when we get to this, my model, I define a variable here called my model. Okay, here I'm mapping this function to each of the x value. That's why I put my func, which is the function name, comma x. I'm mapping, look at the map function out here, and means that I'm mapping each of x value to this my function that I've created here. So I'm putting it in the list form. That is why you see the list function here. You can refer to my previous videos on data structures, what we did list, so you will know what is it. Whenever you have a list function, anything that is enclosed inside that list function will appear in a list. Okay, so that's what happened here, mapping the each x value to the function, mapping them inside this function, okay, to give us y. So now what I wrote here is plt dot scatter, that is x comma y, which means the scatter plot. Okay, now our plotting the x, and this my model is representing the y axis, okay, which we are mapping this. So here we are saying the x label. Anytime you use the x label, it means that you are labeling the x axis. You want to give the x axis a name, and here we are giving dot y label, means we want the y label to have a name beneath it called calorie burnage. Okay, so once you are done with arranging your plot, you just say plt dot show function. Okay, when you do that, let's run this and see. Okay, I think we are having an error here. Okay, why is it throwing us an error? It says start is not defined. and start is not defined. Okay, in defining the start, I think we have to okay, all right, now we have to import stats from SciPy. So let's run it. Okay, now you can see our plot now. And there are few parameters here, that there are few things that we have to look out for. We can look out for the slope, the intercept, the R, which means the relationship, the P, which means p-value, this STD, ERR means standard error. Okay, now we can find all of that. Run it. Yeah, now we'll continue with the regression table, and you can see I've imported the required library to create a regression table, which is statsmodel.formula.api as SMF. SMF represents the alias, which represent the entirety of this library we imported there. So what I'll do next is I have to after running it, then we have to actually import define this. So I created a variable name called my model to hold the library, which stands for smf.ols. This ols means ordinary least square, which is a model for this operation. Now calories for our dependent variable and duration are independent variable. You just put it that way, comma, then our data in which we loaded. This is the variable name presenting the data. Now these are my model.fit. I gave it a variable name called result, and this actually holds the entire information of the model. So here I did a result.summary function, which would output the summary of everything that this regression table holds. So if I run this now, you see what it has given us. So start by explaining some few parameters there, but I'll not go into details. Here we have deep variable, which means the dependent variable, which is calories. So we have here the model, which I told you ordinary least square. So these dates, this time represent the date and the time which we ran it. And you can see this is Friday 23rd February 2024. So and actually we have a COEF here, which stands for coefficient. Okay, so here this stands for standard error, this t value, this is p value, and this 0.025 and 0.975 is the confidence interval. Okay, all right, let me just explain what the p-value actually means. The p-value is a statistical number to conclude if there's a relationship between our variables, that is the duration and the calories. Now we can test if the true value of the coefficient is equal to 0. Okay, now you know that if a coefficient is equal to 0 means there's no relationship, because there's no way the independent variable is affecting the dependent variable. Okay, so you can see in our regression table that we are having a p-value here of 0.000, which means that the p-value is lower than that, it is less than the 0.05 threshold. Okay, which means that the duration and the calories, there exists a relationship between them. Now what this means now is this duration you are seeing here, we have 5.7309. this means that if the duration increases by 1, then the dependent variable, which is the calories, increases by 5.7309, which means this is a very, very, very significant and ideal relationship. Yes, the relationship is significant. So but if in this case maybe we are having 0.8 something or 0.5 something as the p-value, it means that it is a kind of the percentage that disagrees that there's a relationship. Okay, so I think this alone can help us. So thank you very much.